All right, everyone, we are on to lesson 3, which is learning about the Pythagorean Theorem, something that is likely new to you, okay? Or maybe some teachers may have covered it in elementary school, but most likely it's new to you, and I'll teach it from scratch. And the lesson is called Pythagorean Theorem and slant height, okay? So what we're going to be doing is concentrating on triangles for this lesson. And we're going to be finding unknown side lengths of specifically right angle triangles. Okay? And by right angle triangles, I mean triangles, and that's not a great drawing, but triangles that have a 90-degree angle in it. Okay? So this little box that you see in a triangle implies that there is a 90-degree angle within it. And if you see that 90-degree angle, you'll be allowed to use this Pythagorean theorem, because this theory or this formula, it's just a formula, okay? This formula applies to only right angle triangles. So that's only 90-degree angle triangles. So I'm going to take you through how to use the formula and how to solve for all the different side lengths in a triangle. Okay, so let's start by taking a look at essentially what the formula is and how we're supposed to label the triangle. So again, this formula is going to help us find unknown side lengths of right angle triangles, but we have to know at least two sides. Like, we have to know two side lengths to find the third side length in a triangle. All right? So, in words, so we're going to learn a new term here. It's called the hypotenuse. The hypotenuse is the longest side of your right angle triangle. It is always opposite of your 90-degree angle. So, I want to make a little note here where it says hypotenuse. That is your longest side in a 90-degree triangle. Okay, so it's your longest side. And it is always opposite of your 90-degree angle. All right, so it's important that we always identify the hypotenuse, the longest side of a right angle triangle, as soon as we get a question here, because the formula requires us to plug in a number for that specific side called the hypotenuse. And so we have to be able to identify where that side is so that we can take that number when it's given to us and plug it into the right spot in our formula. All right? So here's essentially the equation. It is, and it's got exponents in it. It is the hypotenuse squared is equal to side squared plus side squared. Now, that's in words, but as letters, as mathematical variables, we use this formula right here. And that is c squared equals a squared plus b squared. Okay? But your c has to be the hypotenuse, and this is why you have to be able to identify the hypotenuse. So in any triangle, so I'm going to draw a triangle right now, a right angle triangle. Okay, any right angle triangle. Your c has to be where the hypotenuse is. So if, let's say, the hypotenuse was 10 centimeters, for example, you would have to plug that 10 in for c. C represents the hypotenuse. Always. Okay? So the other two letters, A and B, you can probably assume where those variables go. They go here and here. And for those two variables, it doesn't matter where you put them, as long as you labeled your C or your hypotenuse, the longest side, as long as you've labeled that, the A and B are interchangeable. So you could put A in this spot, or you could put A in the base of the triangle and put B as the height of the triangle. It doesn't matter. You'll get the same answer regardless of what you do there. But you just absolutely have to have C as the hypotenuse. All right, because then you will get, if you plug in C for a different letter, you will get a different answer. All right, so you're looking at this formula and you're probably saying, why on earth is the formula for Pythagorean theorem to solve an unknown length of a triangle? Why is it C squared equals A squared plus B squared? Well, I'm not going to get into it in too much detail. You'll have to, for one thing, I'll ask you to trust that that's what the formula is. But if you just want to see really quickly where that comes from, I'm going to pull up. Okay, so here is the image that I want to show you. And it's a right angle triangle with side lengths 3, 4, 5. You can see that they have side lengths 3, 4, and 5 on the screen there. And what you see is squares attached to each side length. So there's big squares. So a large square made up of little squares attached to each side of the triangle. And so what Pythagorean theorem says is that the hypotenuse squared, meaning a square attached to that hypotenuse, will always equal, okay, the sum of the squares of the two other sides. So if I count the little squares, see where the 3 is? If I count the little squares that make up that bigger square, I have 9 little squares. Okay? And then where it says, so remember that number 9. And then where it says that the side length is 4, if you were to draw a big square at that side length, you would get 16 little squares. So we would get 9 little squares on the 3 side and 16 little squares on the 4 side for a total of 25 little squares if you were to add them together. And not by coincidence, if you look at the side that has the number 5, okay, so our hypotenuse, look how many little squares are there. It's 25. So that hypotenuse, it always equals the sum of the other two sides squared. Okay, so the sum of the other two sides squared. So look at this again, where the 3 is. 3 squared is 9. Okay, and look where the 4 is. 4 squared is 16. If you take 9 plus 16, you get 25, which happens to be the same thing as 5 squared. Okay, so I'm not going to get into too much detail any more than that, but you'll have to take my word for it that the formula works. And if you're any more curious about the ins and outs of how it works, then certainly you can shoot me an email and I can do my best to describe that to you. Okay, so let's go back to the lesson. Now that you hopefully trust that this formula of C squared equals A squared plus B squared can help us solve for an unknown side length. Okay, so let's make a quick little note here that the Pythagorean theorem can only be used in right angle triangles, and by right angle triangles I mean 90-degree angle. So one of the angles has to be 90 degrees. All right, so let's just get right into an example and I'll show you how to use the formula. Okay, so in this first example, and then we'll continue to just finish these questions on this page, and then I want to do 2 more other examples as well. Okay, so I'll get to the reason why I want to do those other examples, but let's just finish these off first on this page here. All right, so take a look. Your longest side of the triangle is where? Okay, so remember, you always have to identify the longest side as the hypotenuse, and it is where your C is. So it's already properly labeled. All right, so the C is already there where my longest side is. And so I'm happy with that. So what I'm going to do is just write out the formula. C squared equals A squared plus B squared. All right? So straightforward enough. I'm going to leave C squared as it is because that's what I need to solve for, right? Like I need to solve for C, correct? I need to solve for C. So I'm going to leave C the way it is. But for A and B, I can substitute values in for A and B, right? What's my A and B? Well, let's call this A, and let's call my 12B. Now, remember what I said earlier. Does it matter which numbers you assign to A and B? No, they're interchangeable. As long as C is the longest side, the other two sides are interchangeable. So it doesn't really matter. And you'll see in the formula why they're interchangeable. I'll explain in a second. So let's write C squared equals, instead of A squared, let's write 5 squared plus 12 squared. Okay, so why are they interchangeable? Well, 5 squared plus 12 squared is the same as 12 squared plus 5 squared. So it doesn't matter which order you write those in. So it doesn't matter which you assign A and B, you're going to get the same answer. So C squared equals, remember to follow BEDMAS, so do exponents before you add. 5 squared on your calculator, that's 5 times 5. Or if you know where your squared button is, use your squared button. It's 25 plus 12 squared is 144. So we get C squared equals 169. Now, I can't stress how often students will leave this as the answer of 169. You cannot do that. That is not fully complete. Why is it not complete, you might ask? Because we don't have C by itself. We have C squared equals 169. So we have to move the square, the exponent 2, we have to separate it from the C. That's always your last step. Your last step is to separate the exponent from the C. Okay, so pay close attention here. Now that we have done our polynomials unit where we learned how to solve equations, we know that when you want to bring something across the equal sign, you have to do the opposite operation. So if I wanted to bring the squared to the other side of my equation or the other side of my equal sign, what is the opposite of squaring something or of squaring a number? It is square rooting. So it almost looks like a division bracket, but it's not. It's on your calculator. It'll look like this on your calculator. So make sure that you can use that button on your calculator. I know every calculator, or there's not every calculator, but a lot of calculators are different in the order in which you press the button. Some calculators, so if I were to do the square root of 169, okay, some calculators I know that you would first have to press the square root button and then press 169. Other calculators, you have to first put in 169, then press the square root button. So you really have to know your calculator, and all you can really do is trial and error and try it out and see what works for your calculator. All right, so once you do that, once you take the square root of 169, you should get 13. And now that makes more sense, right? Like if you got an answer of 169, how could that be when your sides here are 5 and 12, right? You always want to, double check to see if your answer makes sense. 13 is a much more reasonable answer as opposed to 169 here. It wouldn't make any sense that side C would be that large, right? So your final answer is 13, and let's put our units millimeters. At this point, it's probably a good idea for you to pause the video and to try this question on your own right now. Okay, so apply exactly what I did on this side and try that question on your own. So it would be a good idea to pause at this point. Of course, I'm going to move on and I'm going to try this bottom question here. Okay, just so that we can get the hang of it. All right, so remember, first thing you want to do is double check, is it a right angle triangle? Yes, it's a 90-degree angle triangle. Where is the longest side? It is always opposite of the 90-degree angle. So in this case, it's our C. All right, so there's C. That is what I'm going to be solving for. So I can write out the formula. C squared equals A squared plus B squared. Right? And does it matter what I assign A and B? No. So I'll just make that A and I'll make that B, but they're interchangeable. All right? As long as I know here that I'm solving for C, the longest side. So here's C. So C squared equals 12 squared plus 9 squared. So C squared is equal to 12 squared is 144. That's 12 times 12 on your calculator. Plus 9 squared is 9 times 9, which is 81. Okay, so now, of course, write out your C squared equals, and in your calculator, do 144 plus 81, and you will get 225. Okay, and take the square root of 225, and you will get 15. And I'll show my step here, of course. I'm now bringing the squared over to the other side of my equal sign. So I need to do the opposite operation of squaring, and that is square root. So they're all going to follow this pattern. You just have to remember that your last step is always to square root the number. It makes no sense that your answer would be 225 here. How could your side length be that large, right? It just can't. All right, so that can't be. So at that point, remind yourself, that's right, you need to take the square root. And so my final answer then is C equals, okay, 15 meters. Okay, so let's recap. My longest side, C, is what I was solving for. My A goes here, my B goes here, but remember A and B are interchangeable. Plug your numbers in, follow BEDMAS, do your exponents first before adding. All right, and then in the very last step, make sure you square root that number. All right. Okay, so again, I would pause the video and you should try this question here, which is very similar to the question we just did. All right, so give that a shot. Once you're done that, I am going to move on to a different type of question. All right, so in the last two examples I just did, I had to solve for the longest side. In both examples, notice I solved for the longest side. Now I'm going to ask you this. What if I was given the longest side, all right, so I was given the length of the longest side, and I had to find either A or B, all right? So what if that situation comes up, which that happens all the time. So I'm going to take us down here, and I'm going to draw my own triangle, and actually what I'll do so that you can see that it works, I'm going to steal one of these. I'll steal this triangle that we just did. I'm going to do that exact same triangle, except I'm going to leave A as just A and not 12. All right, but I'm going to use B9 and I'll use C as 15. All right, and we're going to work through it and we're going to see if we can get A equal to 12. So I'm going to draw that same triangle here. All right, so I'm going to draw that same triangle. okay? Where I'm going to call this A, it's going to be unknown. I'm going to call my B value, so I'll call this, 12, and I'll call this 15. So you are going to see questions like this, where you have to solve for A or B, all right? When that's the case, I want you to write out the formula again. Watch how this is now different. Okay, so watch closely. In the previous question, we solved for C, right? But in this question, we are given C. We're given the hypotenuse, the longest side. Remember I told you that the longest side has to be C. So that 15, it is not interchangeable with anything. It absolutely has to be C. All right? And this I will call B. If this is A, then let's call that B. Now let's plug everything into my formula. If I replace C with 15, because it's my longest side and it has to be C, I'm going to leave A the way it is because I'm going to solve for A, so I don't know what A is. So I'm just going to keep it as A squared. And then I'm going to add, instead of B squared, I'm going to say that my 12 is my B, so 12 squared. Okay, and I should put the 15 in brackets as well. Okay, so now let's follow BEDMAS, right? So let's do my exponents because I can do 15 squared on my calculator and I can do 12 squared. So I may as well solve what those equal individually. 15 squared is 225. A squared, I mean, it's the same thing. I don't know what it is. And 12 squared is 144. 12 times 12 is 144. This looks different than above, doesn't it? Like, look at above. Look at here. Look, I was solving for C, and I already had C isolated by itself on one side. Look here now. I'm solving for A, and it is not isolated by itself. Good thing that we did Unit 5 polynomials and solving equations, because now we know how to get A by itself. Well, we need to move the plus 144. We need to move it away from A. Okay, that's from last unit. We need to move it away from A. So it has to go on the other side of the equal sign. Okay, because we need to solve for A. We have to get it by itself. So if we're going to bring it across the equal sign, what's the opposite of adding 144? Well, it's subtracting 144. Okay, so I moved it over. I subtracted 144 on the other side to keep things balanced. Okay, keep my equation balanced and true. Look at what you get here. 225 minus 144 is 81. Now I know what you're thinking. Oh, is 81 my answer? Nope. Make sure you square root, right? Because you have A squared equals 81. You want to square root on the other side. So bring the squared over and square root 81. And that's what A equals. Well, the square root of 81 is 9. And guess what? If I scroll up, look what A equaled. Okay, so I labeled these. I labeled them not in the same order that I labeled them before, but it doesn't matter. You can see that one of my side lengths was 9, the other one was 12. And if I go here, one of my side lengths is 9 because I found A to be 9, and my other side length is 12. So this checked out. This worked. Okay. So what I'm trying to show you is that you will be asked to solve for either C or A or B. C is the easiest one to solve for, the hypotenuse, because C is already by itself in the formula C squared equals A squared plus B squared. When solving A or B, you have to do this one step, right? This one additional step right here where you bring over whatever you're adding. If it's plus 144, you're subtracting it on the other side. So you're doing this additional step, okay? You're doing this additional step. All right, so I'm going to do one more example of this just so we get the hang of it. Okay, so I'm going to do one more on this side, and I'll go a little bit quicker with it since we've gone through it once. Okay, I'm going to take a triangle that we've already worked with again, so I'll use the first one. So 5, 12. Okay, so let's call this now, let's do my 12 here. Let's call, instead of calling this 5 here, I'll just call it, actually let's do it the other way around, just to be different from the last question. Okay, let's call this just B, it's unknown. Let's call this 5, and let's call this 13. So it's the exact same triangle that we did in the first example. The only difference is I now gave you the 13, whereas last time we had to solve for that 13, right? This time we're solving for B. So again, write out your formula. That's always step 1. Make sure that your C is your hypotenuse, the longest side. You cannot sub a 5 there for C. You can't do it. It will not work. Your hypotenuse has to be what C is. So that has to go there, and let's call 5. I'll call that my A. So it's going to be 13 squared equals, instead of A, I'm going to put 5. All right, pull out your calculator, and you can do 13 squared, that's 169. 5 squared is 25. And then write out the rest, because you can't do anything with the B squared yet. I know that I need to get B squared by itself, so I need to bring the 25 over to the other side. Well, how do I bring over that 25 to the other side? By subtracting it, because it's a plus 25 on the right. Okay, even though you don't see the plus in front of the 25, it's understood that it's a positive or plus 25. So it's 169 minus, right, the opposite of plus, 25 equals B squared. Remember to write out your equals B squared. 169 minus 25 is 144. So 144 equals B squared. Once again, you're not done. Do not forget that you have B squared. You need to square root the other side, all right, to remove the square, right? So bring the square over, it becomes square root of 144. And guess what the square root of 144 is? 12. And if I scroll up to that first triangle, look at that, you can see the 12. All right, so that's the side that we solve for. Hopefully that proves to you that this Pythagorean theorem, this formula of C squared equals A squared plus B squared, that it works, it checks out. You can solve for either C or A or B, just like we did in all of these examples here. All right, I strongly suggest that you cover up, or you pause the video, you cover up one of my answers, just draw out the triangle that I drew, okay? Try it for yourself, and then double check my answer to see if you did it correctly. Strongly suggest you do that, okay? Where are we going with this? Well, in the coming lessons, we're going to use Pythagorean theorem to help us solve volume questions, all right? So